since we've talked about slope, let's talk about some different types of graphs and relationships that we can talk about. There are line graphs and there are scatter plots. So on the left here, it says line graphs, you have connected points. When you have the connected points, it shows the increases and decreases that we learned was called slope. The graph has meaning between the intervals. Let me pull down my screen here a bit. On the left, we have the title is plant growth. Along the x-axis, the independent variable is time in days. Along the y-axis, it says height in inches. Now, this is talking about a plant. And because the height can include fractional amounts, you draw a line. So the plant does not come out of the ground for 2 days. So you know when you put a seed in the ground, you drop it down in here. It might not pop up out of the ground for a couple of days. And then it continues to grow slowly. You've seen some of those time lapses ones. And then it grows into whatever it is. There's a flower for you. But if it's a line graph and you have connected points, it's because you can have fractional amounts. Because you can have a plant that is half of a foot tall. Now, on the other hand, you have scatter plots, and they show something called correlations. You may have heard of that last year. When you have a scatter plot, you do not connect the points. It's units that can't be expressed as a fraction. So if we look at this one, this is called remaining animals to adopt. Along the x-axis, your independent variable is time in days. Number of animals is along your y-axis, your dependent. Now there are dots here because animals cannot be measured in fractional amounts. So you can't connect the dots because that would represent half of an animal, and you cannot adopt half of an animal. Scatter plots, line graphs. The next section talks about correlations. And you can make a correlation when you see scatter plots. Now, scatter plots compare two different sets of data, and they show how one affects another. So, this scatter plot has points that rise. If the points rise, it's called a positive correlation, like a positive slope. If the points trend down or they fall, that's called a negative correlation, like a negative slope. And if the points have no pattern at all, they're just scattered everywhere, we say that that has no correlation. There also is strong correlations versus weak. If we take a look at the one on the left, notice that the points are tight to a line. If you drew a line through them, there's kind of a line there already. So if the points are tight against a line, that's called a strong correlation. And then if the points don't go tight against your line, that we call a weak correlation. And from your science experience, do any of you know what this is called? This point that lies way away from the rest of the data? It's called an outlier. Okay? Let's go to the back. So we have to figure out if these are positive correlations, negative correlations, or no correlation. Put a little asterisk up here. As the first scenario increases. Now, why do I write this? Every time you do this, the first scenario has to be increasing. You ask yourself, does the second scenario increase, decrease, or have nothing to do with it? Okay? And that tells you if it's a positive correlation, negative correlation, or no correlation. So, you say to yourself, as the time you study increases, because this is always increasing, first scenario always increasing, should your grades increase, decrease, or have nothing to do with study? Hypothetically speaking, your grades should increase, so that's positive. But we all know that sometimes you can study your butt off, but you can't get your grade any better. But as long as you're trying your best, that's all we ask. Second one, temperature. As the temperature increases, it's hot, and the number of people attending a public pool, typically the hotter it is, the more people that are going to a pool, so that is also positive. Next, as the temperature increases, the number of people at a ski resort. Well, if it's getting hotter, what's happening to the snow? It's melting. So the number of people is going to decrease, so this would be negative. Your age, no, this is month of your birthday. January, February. As the month increases, goes up, and the student's grades. Do your grades have anything to do with the month you were born in? No. So this is a no correlation. Next, says age and shoe size. As your age gets older, from a baby till you get older, typically your shoe size increases, so this would be positive. And the last one, the distance from a basketball hoop increases. So, here's my drawing, here's the hoop. As the distance increases from the hoop, gets farther away, the number of basketball baskets made typically decreases, so this would be negative. Hopefully you understand those. If not, make sure you email me. Number 7, multiple choice. The scatter plot shows a relationship between the outdoor temperature and the number of customers in an ice cream store. Which best describes this relationship? Well, first, you should notice that these are trending up. So this is not negative, and it's not no. So it's a positive correlation, and is it strong or weak? The points are farther away, so this would be a weak positive correlation. And the last one says, the scatter plot shows a relationship between the TVs purchased and prices. Which best describes this? Well, these points are going down, so that has to be negative. So we're going to get rid of the positive ones. And is it strong or weak? This one is strong because they are tightly together.